Hello everyone. In this video we're going to be solving a log system. So we have x to the power log y is equal to 2x minus 5 and y to the power log x is equal to x plus 12. And we're going to be finding the x and y values. Here log is used in base 10. That's what I mean by log, not the natural logarithm. I want to make that clear because I know there's been some confusion before. So where does this problem come from? This problem comes from SyberMath. Okay, so I basically thought about this and I kind of found a really nice identity. Well, it was known for a while, but I just thought about this idea like this would make a good problem, I think. And please let me know what you think. Anyways, let's get started. So we have this system, and this system, when you look at it individually, like each piece, it kind of looks a little confusing, right? We have x to the power something, and then it's equal to 2x minus 5. So it's not a standard equation if you look at the first one or the second one. In other words, it's not a standard system. So the solution method is going to be real nice though, I think, in my opinion. So what are we going to do? Well, we're going to be using an interesting fact here, which will make the solution of this problem easier. Now, if you just try to solve this problem separately, like look at each equation and see what you can do, you can probably try to get the log y by itself and write somewhat y in terms of x, and then plug it into the second one. Well, maybe we can try that. Well, how about that? Let's do it. Okay, so what I'm going to do is I'm going to be taking the logarithm of both sides. So let's go ahead and use base x here, log base x, x to the power log y, and this is equal to log 2x minus 5 base x. Okay, so obviously this is going to move, as you know, the power rule, and log x base x is going to be 1, so we can safely say that the left-hand side is going to be log y, and then the right-hand side is going to be what it is, right? Something. Doesn't really matter as long as it's in terms of x, so that's cool. Now, what we can do with that is we can basically, replace the y with that, but we don't have a y, right? What do we have? We have log y, so why don't we just raise both sides, not to the 10th power, but 10 to the power both sides. How about that? Okay, so 10 to the power log y is equal to 10 to the power log x something. All right, so now this is going to be, hopefully you know that this is equal to y. If you don't, then we can kind of prove it, but I think you should already know that. But anyways, this is equal to y, so y is going to give us this value here, 10 to the power log x to x minus 5. Now I can just go ahead and take this, replace it here, and that's going to give me something, not so nice, but anyways, 10 to the power log x to x minus 5, so on and so forth. Okay, you see, this kind of seems to complicate things, and it's going to be super complicated, but I have a better method for you. Come on. We're going to have to solve this using some magic powers like before. Okay, what are those? Well, it just depends on one basic identity. And I'm going to present the identity and then I'm going to prove it. So I'm not just going to give it to you, okay? So the identity is basically that, and you'll be surprised at it if you haven't seen this before. It's that x to the power log y is equal to y to the power log x. And you're like, what? Where does this come from? Well, I'm going to show you why this works and something that you can always use. But let's go ahead and prove that first. So how does this work? Well, since I don't know if they're equal at first, let me go ahead and call this A and let's call this B. So my assumption is that, okay, x to the power log y is equal to A. So what I'm going to do is I'm going to be logging both sides, which makes sense. And base 10 is okay here. You can use another base too, but it doesn't really matter. No big deal. Okay, so keep it simple and use base 10. Now, obviously, log y is a power, so we can move it to the front and write it as log y multiplied by log x is equal to log a. Now, this doesn't really give anything substantial, but let's go ahead and do the same thing for b. So we have y to the power log x is equal to b. And then if you log both sides again, you're going to be getting log y to the power log x is equal to log b. And then again, power rule, log x can be moved to the front and just becomes a coefficient. Log x times log y is equal to log b. Again, this is not very significant, but when you look at these two things, okay, log a is equal to log y times log x, log b is equal to log x times log y. As you know from the commutative property, it's kind of something hard to say, these two are equal. What is that supposed to mean? If two things are equal to the same thing, then they're equal, right? So it means that log A is equal to log B. And if you just forget about the logs, or you write it as 10 to the power log A must equal 10 to the power log B, obviously, right? Because they're two of the same number, and if you 10 to the power that, you'll get the same thing basically. But 10 to the power log A is equal to A, and this is B, so that means A is equal to B, which proves our assertion. Now, you might be wondering why 10 to the power log A is equal to A. Let me just tell you why. It's really quick, actually. The proof is kind of easier. It's not that complicated. So we're trying to prove that this is equal to A, right? So how do you prove that? Let's call that X. And then let's log both sides. Again, the same idea. You just keep logging, right? Okay, keep logging. And then this is going to be moved because that's a power. So you're going to get log A times log 10 is equal to log X. But log 10 is equal to 1 because this is base 10. So we can get rid of that, and it gives us A equals X, which basically proves our assertion again. So 10 to the power log A is equal to A. We just proved it. Same thing for B. Cool. Now we established that what? We established that X to the power log Y is equal to Y to the power log X. Something nice, because this is a really cool identity, and it's going to be super helpful, of course, solving our system. And what is our system? Well, our system is basically, we have X to the power log Y is equal to 2X minus 5. Let's write it down. X to the power log Y is equal to 2X minus 5. And then we have X to the power log Y to the power log X is equal to X plus 12. Okay, great. So now we know that we have a lot of information, right? We know that X to the power log Y is the same thing as Y to the power log X. In other words, you can just switch X and Y around. It won't make a difference. That means that the right-hand sides are also equal, right? So that gives us that these two things are equal. Basically, you're just talking about solving a linear equation. Come on, you can solve this, right? This is super easy. Now, when you set those equal, because the left-hand sides are equal, you can just subtract X. This is going to give you X equals 17. So we got the X value. Great. Awesome. Now we're going to find the Y value. How do you find the Y value? By substitution again, right? So it doesn't matter which equation you use. Again, it's just a matter of taste. But I'm going to use the top one because it has X in the base. So I don't know. It just makes more sense. So let's go ahead and use this equation and substitute 17 for X. Replace X with 17. So this gives us 17 to the power log Y is equal to 2 times 17 minus 5. 2 times 17 is equal to 34. 34 minus 5 is equal to 29. Awesome. So we got another log equation, but log is in the exponent. So why don't you just bring it down? To be able to bring it down, we're going to log both sides again. So if you have anything in the exponent as a variable, you want to bring it down. And the good way to do it is just logging both sides. Maybe the only way. Okay. So what am I going to do though? Which log am I going to use? Well, let's go ahead and use base 17 here just for change, because our base is 17. So why don't we use that? Okay. So I'm using base 17 here as my log, and we're logging both sides, basically base 17. This is nice because log Y can basically be moved to the front and multiply by this whole quantity, and it just becomes a coefficient. So we get log Y multiplied by log 17 base 17 is equal to log 1729. Okay, now what is log 17 base 17? It's equal to 1, right? Because the question is 17 to the power what number equals 17? The answer is 1. So we can just basically get rid of that, and that gives us log Y. Log Y is equal to log 29 base 17. Obviously, I'm trying to get Y here, not log Y. So let's go ahead and do 10 to the power both sides. And that's going to give us 10 to the power log Y is equal to 10 to the power log 29 base 17. Okay, again, remember we proved it. 10 to the power log Y is going to be equal to Y because the assertion was, remember, 10 to the power log A is equal to A. So basically 10 and log with base 10, basically they're going to undo each other. And from here we get Y is equal to 10 to the power, obviously nothing happens on the right hand side, is going to be this expression, which is log 29 base 17. Okay, what is the X value? X is equal to 17, and that basically concludes our video and brings us to the end of this. All right, so thank you for watching. I hope you enjoyed the video. let me know. Don't forget to like, comment, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.